So here you have different parts of the CPU that we already talked about. We already showed this in a diagram, but I want to focus on the registers now. So we have basically a small amount of memory and very fast storage inside the CPU, and that's our registers. So on MIPS, so this is very specific to MIPS and what we are doing in this course, we have actually 32 different registers, and they are indexed also from 0 to 31. So you can refer them like that, and we always have the dollar sign, so it's $0, $1, and so on. But also you can refer them with some names. So if you are working in like the IDE, you can type, for example, dollar, like S1. So that like it's named, but it's essentially it's 32 different values, but some of them are named, so you can like easily work with them and basically just not to confuse them. There are different use cases for each, and some of them are read-only, some of them is used only by the processor itself, some of them you can use as the programmer. So we're gonna like actually get to know different registers. So here we have some and then table, like you don't need to memorize this, but you should like know the broad categories of each and what they are doing. um, I'm not gonna explain like all of them, but there are some important ones. For example, we have 0, and you can use also $0, and that's hardware to the number 0. So if you are using the number 0, you can actually use this. So this comes handy in some places that you're gonna see later, that this is used to do some arithmetic operation, for example. The other important ones that we have, for example, let's look at these T registers here. So basically we have 8 registers from 8 to 15, T0 through T7. So we have T0, T1, T2, and so on. And this is just some register that you can use as a temporary value. So if you're calculating some value, these are some, you can think of it as some variables that you have to temporarily store some value. And it's gonna be basically preserved while you are on your program and not calling any other program. Another one that I would note here is the V and A registers. So V is for return address, A is for argument. So if you are calling a function and you're passing some data, you could use this. So here we are seeing a difference between a high-level programming language and the assembly language. So in high-level programming language, you have series of statements, and in assembly, you have instructions. So what is the relationship between those? Is that each statement could be converted to one or more several instructions. So we have seen abstraction before, and we said that abstraction basically hides the details of any system, and you interact with that system without knowing that details. So actually, if you think about the high-level language and assembly or machine language, you see that it's kind of like same thing is going on here, that we have in our high-level language some statements, and the compiler is taking that and making it to some more instructions and then to the bytecode. But basically what is happening is that this is what is being executed on the CPU, but you don't need to know the detail if you are working in a high-level language. This diagram is showing how the program is being loaded into the memory. So basically when you have your compiled code and you want to execute that program, first thing that happens is being loaded into your memory. So every line of that program or every instruction gonna be in a memory location sequentially. So that's gonna be like all the active programs. So this program could have some other data that is in your memory also, but CPU keeps a track of basically the current line of code that is being executed, and that's kind of like the pointer to that line of code.